What is Python? Python is one of the most widely used programming language in the world. So many organizations nowadays have switched to Python for their functioning. Python is a general purpose, interpreted, interactive, object oriented and high level programming language. So the most important feature here is interpreted. So there is a Python interpreter that compiles the output one line at a time in Python. So it is dynamic open source programming language with a focus on simplicity and productivity. So basically Python is open source and you can download all the source code for free, and it is dynamic language with focus on simplicity and productivity. Python has an elegant syntax that is natural and easy to write. So the same code that performs the same output in Java can be written in Python in a better way and in a more elegant and smaller syntax. Python is a beginner's language. Python is a great language for beginner level programmers and also supports the development of wide range of applications from simple text processing to World Wide Web browsers and to games. Guido van Rossum created this during 1985 to 1990. Python is an open source programming language and its source code is available under the GNU General Public License. Some key features of Python are: Python is interpreted. Python is processed at runtime by the interpreter. You don't need to compile your program before executing it. This is similar to Perl and PHP. I have discussed this earlier. Python has an interpreter that compiles the whole program line by line, one line at a time. Python is interactive. You can sit at Python prompt and interact with the interpreter directly to write your programs. So as you can see here, you can open the Python interpreter and type one line of code and hit enter, and it will run that line of code. Python is object oriented. Python supports object oriented style or technique of programming that encapsulates code within objects. Features of Python. Python is simple, beautiful, and it is easy to learn and write code in it than other languages. So as we'll see in coming slides, the same line of code can be written in a smaller way in Python than in Java. Python is object oriented. So as you know, Python supports concepts such as polymorphism, operator overloading, and multiple inheritance, which are object oriented features. Python is free. I have said this before. Downloading and installing Python is free. Python is portable and powerful. So it runs virtually on every major platform used today, whether it is Linux or Windows or Mac. Dynamic typing, built-in types and tools, library utilities and automatic memory management are some other features of Python. So in this slide you can see Python versus Java in action. So the same line of code that is written in Java to print a simple hello world to the output can be written in Python as a single statement of code. Versions of Python. Basically there are two main versions of Python, Python 2 and Python 3, where version 3 is the preferred version nowadays, with version 2 not receiving any support or bug fixes and updates. You can refer to the Python wiki link here. There are few key differences in both versions, with the result of Python 2 code getting outdated and requiring to migrate source codes of previously written Python 2 projects to migrate to Python 3. So if you have written code and projects in Python 2, nowadays more often they are needed to require to migrate to Python 3. If you are looking for a Python book reference, I personally recommend this free book in which you can download the free PDF version as well. So this is the Think Python by Alan B. Downey, and it is a very good reference for beginners. So you can go to this link and download the book for free. Now we start off with our simple Python application. So what are the steps to print hello world in the output cell in a Jupyter notebook is demonstrated now. So you can open the Jupyter notebook application and select new and then select Python 3 on the far right corner. This will open up a new notebook, and in the cell that is titled 1, type the following: print hello world, and then press shift key and enter key together to run the current cell alone. This will print hello world to the output. Arithmetic operators in Python. So we'll see what all operators we can use with arithmetic operands in Python. So that is, these are the operators that we can use with two numbered or other integer or floating types in Python. First one is the operator plus, which has two operands. Example is x plus y. Similarly, we have the minus, multiplication and division and modulo operators. And this is floor division, the double slash here that divides uh, the number on the left with the number on the right, uh, adjusted to the left in the number line. So if the result is 2.6, it will adjust to 2. And lastly, we have exponent. So left operand raised to the power of the right. So this is x to the power of y. Moving on to the comparison operators in Python, we have all of these comparison operators which compare the left operand to the right operand. So we have the greater than operator first, which returns true if the left operand is greater than the right operand. Example, x greater than y. So if x is greater than y, it will result in true, otherwise false. And then we have the less than operand, which works in a similar way. Then we have the equal to, or rather double equal to operator, which returns true if both operands are equal and false otherwise. And contrary to that, we have the not equal to operator, which returns true if both operands are not equal, and if they are both equal, it will return false. Next, we have the greater than equal to, which is an added equal to the right side of the greater than operand operator, which returns true if left operand is greater than or equal to the right. Similarly, we have the less than equal to operator, which returns true if left operand is less than or equal to the right operand. So now we're moving on to logical operators in Python. We have the AND or and not operators as specified syntactically in this column, and specifically written like this instead of the double ampersand sign in other languages, and or similarly and not, whose functions are the same as in other languages. Moving on to data types in Python. Python has five standard data types: numbers, which may be integers or floating point decimals. Next we have strings, and then lists that are just collection of different types of data types in an array sort of format, that is a list format. So but difference between arrays from other types of languages is that in a list we can store various types of data types. So a list can have different elements that have different data types. So similarly we have tuple. There are a few differences in tuples and lists that we shall discuss. And next we have dictionary. So these are key value pairs. We will discuss them now. Starting off with Python numbers. Number data types store numeric values. Number objects are created when you assign a value to them. For example, where 1 is equal to 1, where 2 is equal to 10.5, or where 3 is equal to complex 2, 3. So here the complex 2, 3 creates a complex number of 2 plus 3j. So where the real part is 2 and the imaginary part is 3. So if you output this where 3 to the console, it will print 2 plus 3j. So complex here is the function that creates that complex variable or complex number. Python supports three different numerical types: int, float, and complex. So as you can see here, complex numbers uses the complex function. Python strings. Strings in Python are identified as a contiguous set of characters represented in the quotation marks. So Python allows either pair of single or double quotes. So you can either use double quotes in your strings or single quotes as you feel fit. So when you write like this, my string 1 is equal to hello world, this is a string which is assigned to my string 1, and similarly this is a string which is assigned to my string 2. So when you print both of these strings, it will log corresponding strings to the output. And if you print my string 1 of within brackets 1, so shall log e to the output. Why? Because my string 1 here contains hello world, and the second character is e here. So basically, arrays are indexed from 0 in programming languages. So counting starts from 0 here. So 0, 1. So 1 is here, which is the second element. So it prints to e to the output. When you print my string 1 plus my string 2, it is a case of concatenation, and it will print both strings concatenated to the output. And if you want to print one string multiple times, you can simply specify the number along with the multiplication sign here, and print that string like this. It will print the string hello world 2 times. An interesting fact about strings is that strings are immutable. That is, we cannot change Python strings once they are assigned to a value. So we can assign the same variable to another string that is a completely different string though, but we cannot change a string's element from one to other. So it will throw a type error or an error on the console. But on the other hand, if we assign this string to this my string to, it is a valid assignment. Moving on to Python lists, they are the most versatile of Python's compound data types. A list contains items separated by commas and enclosed within square brackets. So all the items are separated by comma, and the full list is enclosed within square brackets. A Python list is different from arrays in other languages as it can contain items of different data types, as I have mentioned earlier. List can contain list as elements in itself. So we can have a list within a list within a list. So this is a specific property of Python, that we can have nested list within a list. So, and each list can have elements of other types in each as well. So each list can itself have different types of data types in as elements. Now we see example of Python list. Here we have a list which has elements like these, and another list which has two elements like this. If we print list first list, it prints the complete list of this. Similarly, if you want to print the first element of the list of the first list, it will print A, B, C, D, E, and we have to pass as argument to the print function list 0, since counting starts from 0. If you want to print elements starting from second till third, we write something like this: print list 1, 2, 3. So it will print from second position since counting starts from 0. So it will take from second till third. And if we want to print all elements starting from third element to the end of the list, we'll write list 2 and leave the second argument empty here in brackets. So it will take to the end of the list. If you want to print list 2 times, so similarly we can, as a case of string, we can write print tiny list into 2. And if you want to concatenate 2 lists, we can use list plus tiny list. It will concatenate first and second list. A specific property of Python list is that we can access elements from the end as well using negative indexes. So whereas the positive indexes give count from 0 from the start, negative indexes count from right or the end starting with -1. So DEF has index of -1. This list 2, 3 has an index of -2, and so on. So if we give t minus 3, it will give 4.56. Whereas on the other hand, t1 will give the second element, which is ABC. You can change the list in place. That is, lists are mutable. The changed list still points to the original list assigned initially. So if you assign a list variable as this list and you change the second element to be 45 and you print this list, the list will get changed here, and the change list as here will still be pointed by li. Moving on to list operations, we have the append operator that inserts at the last, or insert function that inserts at specified index the value that is required as the second parameter. So if we have a list li as this and we insert I at the second position, we'll get something like this. So counting starts from 0, so this will be inserted at the third position in fact. So this is the second index that is passed and the position is third. Other list operations include index, count, remove, reverse, and sort operations, where sort function sorts the list, reverse function reverses the list, and index operator operation gives us the index of first occurrence of any element which is passed to it as parameter, and count operation counts the number of occurrences of a specific element, and remove operation removes the first occurrence of any element. Now we shall discuss Python tuples. A Python tuple is another sequence data types that is similar to the list. A tuple contains number of values separated by commas. Unlike lists, tuples are enclosed within parentheses. So which are these parentheses? Unlike lists, tuples are immutable. So that is the core difference between tuples and lists, that we cannot change a tuple once they are assigned a value. So we can perform similar operations in tuples. The only difference is we have to declare it using parentheses as opposed to square brackets in list. And tuples are immutable. So if we write this tuple and assign it to t and try to change the second index of t, it will throw an error like this. Object doesn't support item assignment. So tuples are therefore immutable once they are assigned a value, though their elements cannot be changed. Python sets. A Python set contains an unordered collection of unique and immutable objects. The set data type, as the name implies, is a Python implementation of the sets as they are known from mathematics. This explains why sets, unlike lists or tuples, can't have multiple occurrences of the same element. So in a Python set, we cannot have multiple occurrences or duplicate elements. So a Python set is mutable, but the elements aren't. That implies that we can add or insert new elements in a Python set, but their elements cannot be changed. Their elements are immutable, but the set itself is mutable. So a basic example to demonstrate Python sets is shown here. We assign this set to this variable adjectives. So if you output this, something like this will come to the output. And if we pass only one string as a set function to the set function and assign it to variable x, it will create a set out of all the elements inside this string, and thus duplicates are removed from this collection. And when we output this, something like this will come here. And if, as you can see in the final example, there is a cities variable and we have a we pass it to the set function, create a set out of this collection, then in that case the duplicates values as shown here will be removed from this final output. Python dictionary. Python's dictionaries are kind of hash table type. They work like associative arrays or hashes found in Perl and consist of key value pairs. So there is a key having a value and there are multiple keys inside a dictionary. And Python's dictionaries consist of key value pairs thus. So an example of Python dictionary is shown here. So we can assign it in the same way as like sets, curly brackets, and but instead of giving it values is within brackets, we directly write the dictionary variable name, and within square brackets the key name and is equal to the value. So this is the key and this is the value. Similarly, this is the key and this is the value. So when we write like this key will get added to this variable dictionary, and so the this value will be against stored against this key, and this value will be stored against this key. So this is the second way of initializing a dictionary, where we can write like this: name is John, code is 6734, department is sales. So the key name will be having the value John and so on. So when we print specific keys from that variable, it will print the value for that key. And if you want to print the entire dictionary, we can simply pass on the dictionary name or the keys or the values.